Imagine standing on a beach at night, watching as the waves crash against the shore in bursts of electric blue, or walking through a dense forest and spotting a cluster of mushrooms emitting an eerie green glow from the damp soil. These aren't scenes from a fantasy movie, they're real, natural phenomena created by living organisms that produce their own light. The ability to glow in the dark, known as bioluminescence, is one of nature's most mesmerizing adaptations. And the science behind it is just as fascinating as the spectacle itself. Bioluminescence occurs when certain chemicals within an organism interact to produce light. The key players in this reaction are a molecule called luciferin and an enzyme known as luciferase. When oxygen combines with luciferin, the luciferase speeds up the reaction, releasing energy in the form of light. Unlike a light bulb, which wastes much of its energy as heat, bioluminescent light is incredibly efficient. Nearly all the energy becomes visible light, with almost no heat produced. This is why fireflies can glow without burning themselves and why deep-sea creatures don't overheat in the freezing ocean depths. But not all glowing organisms create light in the same way. Some, like jellyfish and corals, exhibit a different phenomenon called biofluorescence. Instead of generating their own light, they absorb light from their environment, usually blue or ultraviolet, and re-emit it at a different wavelength, often as vibrant greens, reds, or oranges. This is why a coral reef can appear to glow under a black light. It's not producing its own light, but rather transforming existing light into something more visible. The reasons why animals and other organisms evolved to glow are as diverse as the species themselves. In the deep ocean, where sunlight cannot penetrate, bioluminescence is a vital tool for survival. Many deep-sea creatures use it to camouflage themselves. Some fish and squid have light-producing organs on their undersides that mimic the faint glow from above, effectively erasing their silhouettes when viewed from below. This makes them nearly invisible to predators lurking in the darkness. Others, like the infamous anglerfish, use a glowing lure to attract prey. The dangling, bioluminescent tip of their fishing rod-like appendage tempts smaller fish into striking distance, where they become an easy meal. In other cases, bioluminescence is used for communication. Fireflies are perhaps the most famous example, flashing specific patterns of light to attract mates. Each species has its own unique code. Some flicker in short bursts, while others produce long, steady glows. Even tiny marine organisms, like dinoflagellates, use light as a defense mechanism. When disturbed by a predator, they emit a bright flash, startling their attacker and sometimes even attracting larger predators that will go after their would-be hunter. It's a brilliant example of nature's arms race, where light becomes both a weapon and a shield. On land, bioluminescence is rarer but no less fascinating. Glowworms, found in caves and damp forests, dangle sticky, glowing threads to trap unsuspecting insects. Some mushrooms, like the ghost fungus, emit a soft green light, possibly to attract insects that help spread their spores. Even certain bacteria glow, sometimes colonizing the bodies of dead fish or decaying wood, creating an otherworldly shimmer in the darkness. Humans have long been captivated by these natural light shows. Ancient mariners told tales of the ocean glowing at night, a phenomenon now known to be caused by massive blooms of bioluminescent plankton. Today, scientists are harnessing the power of bioluminescence for groundbreaking research. By inserting genes from glowing jellyfish into other organisms, researchers can track the spread of diseases, monitor brain activity, and even study the growth of cancer cells. There's even ongoing experimentation with bioluminescent plants that could one day serve as natural street lights, reducing energy consumption and transforming urban landscapes into living, glowing art. But perhaps the most intriguing question is how bioluminescence evolved in the first place. Some scientists believe it began as a way for early life forms to detoxify oxygen, which was once a dangerous byproduct in Earth's ancient atmosphere. Over time, the ability to produce light may have been repurposed for communication, camouflage, or hunting. The fact that bioluminescence has evolved independently in so many different species, from bacteria to fish to fungi, suggests that it's an incredibly useful adaptation, one that nature has discovered again and again. The next time you see a firefly flicker in the summer night or catch a glimpse of glowing waves along a shoreline, take a moment to appreciate the incredible biology work. These organisms are more than just beautiful curiosities, they're living proof of nature's endless creativity. And as scientists continue to unlock their secrets, we may find even more ways to apply their glowing abilities to medicine, technology, and beyond. The natural world is full of wonders, and bioluminescence is one of its most dazzling examples.
Hey there, if you're enjoying this video and appreciate the effort behind it, don't forget to like this video. It really helps the channel grow, and if you haven't already, hit that subscribe button and turn on the notifications so you never miss an update. Oh, and one more thing, share this video with your friends. Spread the love and support. Alright, now let's get back to the video. Let me know if you want any tweaks.